Good afternoon, everyone. I'm Cassie with AABC, and I'd like to welcome you to today's Tab Talk webinar. I also want to thank our sponsor, Integra, for supporting this session. Just a few items to cover before we get started. Our presenters will hold questions until the end of the presentation, but we encourage you to submit your questions at any time using the Q&A button. If you happen to experience technical difficulties during the webinar, please use the chat function to inform the panelists so that our producer, Will, can assist you. This presentation is being recorded and it will be available for viewing in 1 week. In terms of continuing education credit, everyone in attendance for the full webinar today will receive a certificate of attendance sent to their email within 24 hours. And finally, if you're a certified TBE or TBT, your CEUs for attending this webinar will be automatically uploaded to your respective portal after the webinar. Our webinar today is selecting the proper tab equipment to test controlled environments and laminar flow devices. I'd like to welcome our speaker for today, Dan Velasquez. Dan has been involved in the HVAC industry for over 30 years. He began the tab and certification portion of his career in 1997 at MJ Mechanical, a mechanical contractor specializing in design-build cleanroom systems. In 2004, Dan went to work for the John W. Danforth Company, starting as a tab technician and eventually being named operations manager for the company's environmental service department, which included tab and certification divisions. In his time at Danforth, Dan obtained his NEBB Air and Hydronic Certified Professional Stamp, his NSF 49 Biological Safety Cabinet Accreditation, and his CETA Registered Cleanroom Certification Professional Stamp. In 2022, Dan was hired as the Vice President of Cleanroom Services at Mechanical Testing Incorporated. When MTI was acquired by Integra, Dan was assigned to his current role as Senior Technical Support and Training Specialist in their Controlled Environment Certification Services Division. Dan is hoping to focus the remaining years of his career developing the next generation of certification specialists and supporting the rest of the CECS team as needed. In recent years, Dan has also been helping develop standards and certifications with the AABC Critical Environment Certification Council. He is a member of the Fume Hood Committee and the HEPA Filter Testing Committee. In April of 2024, Dan was elected to the Board of Directors of CETA, the Controlled Environment Testing Association. A veteran of the United States Coast Guard, Dan lives in Hamburg, New York with his wife Debbie and daughters Olivia and Ava. For the past 15 years, Dan has been coaching his daughters in softball, but this is his last season. Dan also likes to spend his time in the cold months playing ice hockey and spraying the ball all over the course in the summer months. Without further ado, I'll hand it over to Dan to kick us off.
So real quick, she gave a nice little bio for everybody, but this is kind of a breakdown of it on the slide. So I am a veteran of the Coast Guard, and then there's the career path that I had, starting as I started as a sheet metal installer, but I got too many stitches on the wrist and said let's take a less dangerous task. So I got into testing and balancing back in 1997. So it's been a long, good career so far. So a lot of the learning objectives I want to deal with today, obviously very basically, we're going to go over the tab airflow procedures, identifying the aspects of cleanroom classification and construction that may prevent certain testing procedures from being used and require what may be considered by some in the industry as non-traditional. Also, I want to review laminar flow devices, real brief, that do require testing, explain the instrumentation required and the methods used. And then we'll talk about some industry-based certifications along the way and special testing items that they will look for. If you do have questions, feel free to ask along. So first poll question we have, if Will's kind enough, is how long have you been in the test, adjust, and balance industry? So like I mentioned, I've been doing this for 30 years now, so I'm curious to see what the breakdown is of all the attendees, is how long you've been in this career for. Oh, bunch of old guys. So this for some of the older technicians, and I'd say 20 years or older. Some of this will be a little bit of a review. I didn't dig too deep into it. For some of the newer audience or younger members of the audience, I'm sure this is something very familiar as well. If you have a strong training programs at your firms. So obviously, we all know about the national standards. That's the Bible as far as AABC goes. That's the gold standard. Right in 3.1, it's spelled right out. The primary measurement of airflow in HVAC systems is performed by pitot tube traverse. Very short, very sweet, very succinct, specific. If you're going to measure airflow, the duct traverse is definitely the preferred method to do it. That's something that's as old as time. Obviously, everybody knows they're used. They're very precise. They're reliable, and most important, it's got physics behind it. Using Bernoulli's principle with velocity, pressure, air pressure, converting it to velocity, pressure. It is scientifically robust. It has been tested ages, hundreds and thousands of times. People have put it on rigs, and it is the most reliable test for sure. It gives you consistent results, especially when you space out your tubes. If you mark your tubes, you got your holes drilled, you do the duct traverse 1,000 times, you're going to do it the same way because you got the way you got your pitot tubes measured. So one of the things as far as the certification world you got to think about is accessing the main ducts. Yes, they are very, very accurate. They're very reliable, and there's a reason why it's considered the gold standard. But when we're talking in particular, clean rooms or controlled environments, accessing these ducts may not be available, especially if you're in a very large clean room complex fed by rooftop units, and it's a solid ceiling clean room where you can't get above the ceiling. So it makes duct traverses very hard, makes them inaccessible. One of the things about it as well is you need velocities above 1,000 feet per minute. That'll come in down the road as far as I explain a little bit more about velocities and why the instrumentation changes. So we all know about flow hoods as well. This isn't a commercial. This isn't a sales pitch for any equipment manufacturer. So I'm not preferential to any of them. That's why this slide, there's pictures for each one. But obviously, once you set the main airflows using the flow hood, you want to proportionally balance. Using the duct traverse, you want to proportionally balance the system using the hood. That's after the unit's been set for flow. Obviously, don't forget about your flow factors. If your duct traverse is saying 1,000 CFM and your hood readings are saying 900, you have a 10% flow factor, there could be something wrong with your ducts. In the bigger projects, especially the senior techs, if you get into big tab projects and they got the 230594 specification sections where they will prohibit in tab reports that the hood airflows aren't the summation of the air handling totals. It may be in a different kind of note in the spec, but it'll always say summation of outlets does not mean the total airflow. That's where the duct traverses come in. Do a nice duct traverse on your unit. That's your total airflow. You do your statics, and then after all that information is listed, then you can do your hood readings. There's an age-old dialogue for anybody that's been doing this a long time about back pressure compensation. Over 30 years, I've heard people say they do use it, they don't use it. It's a dialogue. It's a conversation that'll never end, as far as I'm concerned. People do like it. People don't like it. So a little bit more will come down about back pressure compensation as well. So obviously, duct traverses, keep that in mind for setting units. So clean room is a controlled environment designed specifically to minimize particles, contaminants, microbes for sensitive processes and products. There's a whole lot more to it, but that's the long and short of it. It's a controlled environment. So there's examples of controlled environments. Could be a laboratory, could be an isolation room, could be an ante-room. So there's a lot of different rooms that are considered controlled environments. For this discussion, we're going to kind of focus mostly on clean rooms because of the HEPA filtration and because of some of the standards. There's three major types of clean rooms. The traditional hard walls that people have seen, soft wall clean rooms that you may see located in a factory or a warehouse, and they'll have a little clean area. And then I'll have portable clean rooms as well. Portable clean rooms are just that. They're portable. They can be used for all sorts of different aspects of the industry, and they can change based on the processes or products that's going to be used in there. Poll question number 2 would be, how many people have been involved with clean room performance testing. In particular, airflows. It could be the balancing of it, could be the pressurizations of it. But just curious to see how many people have actually done work in clean rooms before. Good. Very, very good. So I'm not talking to total strangers. That's perfect. So obviously, getting back to this, hardwall clean rooms. This is a good example of it. This was a laser etching clean room complex. It's enclosed space built from non-porous materials. They're durable, they're impervious, and they're moisture and mold resistant paneling. Non-porous surfaces for easy cleaning and microbial growth inhibition. The HVAC systems are hard ducted. Most of the clean room industry is going away from terminal HEPA or inline HEPA banks and going more towards ceiling HEPA filters. The industry is kind of pointing that way. The United States Pharmacopoeia Standard 797 clearly dictates that pharmacy clean rooms at hospitals and compounding pharmacies, that the ceiling HEPA filters need to be in the ceilings now. So more and more, you're going to see them more into the ceilings and less at the unitary systems. Good examples of these: pharmaceuticals, biotechnology, semiconductors is becoming a very big industry, as well as aerospace. So off-wall clean rooms, this is an example I got from Terra Universal site. They are flexible controlled environments. They have the curtains. A lot of times you'll see the vinyl curtains. The system, the HVAC, a lot of times they'll tie into maybe one HEPA filter, but the system may have 4 filters in there. So they use a lot of fan filter units where they don't have a central air handler pumping the air through the filters. They'll have fan-powered HEPA units that sucks the air from it. They can be easily adapted and reconfigured. That's one of the nice things about them. And plus, the overall installation cost is kind of low compared to a traditional hard stick-built clean room. Again, pharmaceuticals, biotechnologies, the electronics industry, medical devices, and food processing. You'll see a lot of that in these places. Packaging, quarantine. A lot of places will have manufacturing, and the clean packaging will be done in a soft wall clean room such as this. Portable clean rooms. Biggest thing about portable clean rooms, the mobility. They're self-contained units. They almost always have a blower unit somewhere on the side of it, on the back side of it. There are different manufacturers. Bio bubbles come to mind, where all the ducting is actually sewn into the fabric of the clean room itself. It's got a little blower unit with a HEPA filter in it down below in the back, and then it just blows it through the fabrics. So not a lot of airflow testing you're going to do on these. They're very cheap to purchase and operate. You do see these in pharmaceuticals again, biotech, electronics, and some research and development facilities. You'll see these sometimes in learning colleges and their laboratories as well, where they want a clean environment for one of their processes or one of their experiments. They'll get these portable clean rooms. Excuse me. So, which kind of leads to the 4-letter, I don't know how many people are familiar with IEST, the Institute of Environmental Sciences and Technology. So the IEST is kind of to the certification world like the AABC manual is to the TAB world. They publish recommended practices through their contamination control division. Anything with clean room and laminar flow equipment testing, they are considered the gold standard, just like the technician manual is for TAB work. They're used, their documents, their practices are used in all sorts of industry organizations, AABC included, the CECC through AABC, CETA, NEB, NSF. They all reference IEST recommended practice documents. We have 50 of them published right now, and there's a lot more coming. IEST is a very busy organization with a lot of people with a lot of industry experience. And as they see a need for developing a recommended practice, they'll put them out. If you were to go to their website, which I would recommend on your free time, take a look and see on their bookstore all the different published documents that they have. We're going to focus mostly on two of them, the unidirectional clean air devices and testing clean rooms. All of these can be purchased through their store. This is not a document you'll get for free. You have to buy a licensed copy of it. They do have subscriptions to their library. If you're heavy into the clean room performance testing, I'd highly recommend getting a subscription for it. And you cannot copy them. They are very, very proprietary, but if you're going to get deep into the industry, they're great documents to have. So testing clean rooms. Right now, the best way to say it, that they're used to ensure that they function properly through their tests. They have four primary tests: airflow volume, velocity, and uniformity, HEPA and ULPA filter leak tests, airborne particle counts, and room pressurization tests. A big thing to note, the only industry standard that's published with a pass-fail criteria in a clean room is the particle counting. That's in the ISO 14644 document. That'll specify based on the particle size and the cleanliness concentration of the room, it'll give you what your maximum concentration can be at a location. So that's where the ISO 7 terminology you may hear, ISO 6, ISO 5. That's all based on particle concentrations, based on the classification and the size of the particles being considered. Just big to note, that's the only one that you will see and all the documentation that you read that says this is a pass-fail test. Everything else is upon agreement between yourself and the customer. What's their passing test? What's the airflow requirements, the air change requirements? That's something that as you get in with your conversations with your customers, that's the conversations you need to have. What does their SOPs require? What do they need for a passing test? So these are the four primary tests that we do as clean room testing certifiers. Secondary tests, they do have airflow visualization and smoke pattern testing. You can give customers all sorts of information, all sorts of data about their airflows, their air velocities, their HEPA leak testing. You're giving them numbers. Airflow visualization and smoke pattern tests, that actually can be recorded. It's something they can see, where the air is actually moving. Is it coming, coming out of the ceiling HEPA filters across the work surface and then down to a low wall return or a raised floor return based on the room construction. Lighting level and uniformity. It's an ergonomic test that a lot of sites do request. Noise level testing. There are upper limits for noise level exposure for their workers. Temperature and RH get very critical. Number one's for ergonomic. If you're gowned up in a clean room gown and you're slightly overweight like myself, you get hot as you're moving around. So they want to make sure that the space isn't too hot, it's not too warm. Their workers won't overheat. Relative humidity testing can come in. Anything to do with semiconductors, anything to do with special metals or sensitive processes. If your RH gets too high, it'll start corroding. It can start leading to damage on the materials that they have. Same thing with powders. If you're working in powder manufacturing, you can start, the powders will start to clump together if your RH is too high. Vibration tests. Vibration tests are done a lot of times to make sure that the rooms obviously aren't shaking, because in the ultra low clean room areas, the ISO 3s, the ISO 4s, if you're vibrating a lot, you'll actually vibrate particles from your ceiling fixtures and from the fixtures, and that can contaminate their product as well. So vibration testing does become critical. For non-unidirectional, these are ISO 5 or dirtier clean rooms. ISO 6, ISO 7, ISO 8. When you're testing these for airflow, the volume testing method is preferred. Right out of document 006.3, they specify it's not a requirement. They strongly recommend that the volume is measured using a hood in a manner that includes all of the air issuing from each terminal filter or supply diffuser. That's a very big difference. That's a step in a different direction, considering a tab background where you think of the duct traverse. You got a big clean room, you got a big duct, you take the traverse, you got 10,000 CFM, boom, you're done, right? Well, clean room customers, their SOPs, their quality assurance departments, they're going to want to know the airflow through the filters more than a duct traverse. One of the questions when I took my certification exam was, you have a duct traverse of X amount of CFM, but your hood totals are significantly lower. And it lists 10 reasons why that could happen. So that's one of the big reasons why the cleanroom customers, they require flow readings, because a duct traverse, if a flex falls off, you're not going to know it above a ceiling. You're not going to see it. If you can't get above an interstitial space under production, whatever their work requirements are, you won't know that. So that's why the duct traverse is kind of taken out of the conversation. And the flow hood does substitute that. So it is preferred. Make sure that the hood skirt fits over the entire filter. I've gotten customers in the past because their previous vendor went through with a 2x2 hood to try and read 2x4 filters. Anybody that does a lot of work in clean rooms nowadays knows that anytime you're in a clean room, you're on camera. So the customer saw their certifier doing this because that guy didn't want to walk out to his truck to get his hood. So, and obviously they lost confidence in that vendor right away. We got contacted, and it's a large customer of ours now because we demonstrated that we know how to do it, and we're going to do it the right way, that the hood skirt fits over the entire filter. It does get tough in some clean rooms, some of the European construction models where they have 3x3 radial flow HEPA filtered systems. You got 3x3 hood, it's pretty big. It gets a bit cumbersome, but you still want to make sure you have the right size. So if you can't fit a hood on there, because a lot of times you go to these rooms, they may not have the highest ceilings. They got a lot of production equipment, filling lines beneath the filters where you can't get a hood on. That's when you have to use recommended, either use a Velgrid or a hot wire to get velocity readings and make a K factor to convert that velocity reading to volume. When you report this to a customer, you're going to report your airflow. You're going to report, here's your list of the diffusers, your terminal ID, they'll all be identified. They'll have drawings to provide for you with their terminal IDs, and you'll say, here's your airflow. Some places will also ask for volume tests as well. Velocity tests, I'm sorry. So in this document, the term duct traverse is not mentioned. So it's, I know it kind of flies against what we've been brought up with in the past, but with these IEST documents, duct traverses are rarely considered. A unidirectional clean room is an ISO 5 or cleaner clean room. So ISO 5s, 4s, 3s. ISO 5 or unidirectional clean rooms, they have 100% HEPA filtered ceiling coverage. There are no ceiling tiles. There's light fixtures that are usually underneath the HEPA filters, but the entire area is considered a one HEPA filtered surface. When you get to these clean rooms, unidirectional ISO 5 or cleaners, you don't do volume tests anymore. You're going to do velocity tests. Everything then converts to velocity readings. They don't really particularly are too worried about the airflow as they are the volume. They want laminar flow. They want equal volume across the entire room. This is where smoke testing will come in a lot of times too. If you'll do the velocity test, you'll give them a uniformity test that the whole space is nice and laminar. They're going to want to see smoke tests as well, or air pattern tests is a new term you're going to start hearing. Typically, you're going to use a grid, a Velgrid or a hot wire to do this. So if you're doing a velocity test in the entire plane, you want to be no more than 12 inches from the supply source. You don't need to be real close. You want to be no more than 12 inches away. If you're just testing an individual filter, then you don't want to be more than 6 inches away. So you want to be perpendicular to the flow and supported by a stand. So anybody who's been in the industry for years has probably seen this picture to the right there. That's not considered an accurate way to measure anymore. You get the 3-inch standoffs. Everything's going to 6 inches. And also it's not on a stand. He's holding it up. Depending on how stressful the day is, he may be shaky. It can throw off the accuracy of the readings just a little bit. So I asked what's wrong with that picture. One of it is you're not supposed to be holding it by hand, and number two, the 3-inch standoffs just aren't used that much anymore. Unfortunately, all the grid manufacturers and grid vendors and sellers, they don't supply the 6-inch standoff standard. We're pushing within the industry to have customers or vendors do that. I know I've seen what Evergreen's been doing with their research and development with adjustable legs or adjustable standoffs is really nice. but they do have them available. If you're going to get into the clean room industry, I highly recommend getting some 6-inch standoffs for sure. So like I did mention before, the term duct traverse is not mentioned, it's nor recommended. Again, in a completed and active clean room, they may not want you to go up above the interstitial space, or they may not have an interstitial space where you can't get to the ducts. You saw that picture a couple slides ago. That's a solid ceiling. You're not going to move a tile. You're not going to open an access door. You can't, while they're in production. So they don't mention it. They don't recommend it because they don't also, again, duct traverses, they're very accurate for sure, but they don't factor into issues like a loose flex connection, a broken flex connection, a missing end cap, a missing smoke access door. You name it. I've seen it in the past where it's the tab guy says everything's fine. We go through and we're missing a lot of flow, a substantial amount of flow. And it's not something you can just chalk up to a flow factor. It's like, no, you're missing too much. So then a lot of times you may have to go through, and we've got to cut mastic insulation because there's all the access door holes cut, but they didn't put the access doors in. So again, velocity, using a velvet or a hot wire, use that in places where the hoods can't fit. So the reasoning a lot of times for the flow hood, it gives you the accurate, real-time snapshot of the air actually entering the room and going through, whether it's the diffusers or whether it's through the filters. That's why a lot of the customers will request that information. They want to know each terminal's output. It verifies the balance. It can be used for trend analysis. A lot of times, everybody's probably familiar with the term air changes per hour or air change rates. While it's not a required test per IEST, there are almost every customer I go to or I've worked with over the years, it's a required test as part of their SOPs. They want to know that the air is getting scrubbed and how many times per hour it is being scrubbed by their HVAC and HEPA systems. And it's also a good number to use. What they'll do as you're there every 6 months doing testing and certification work is they'll use that to gauge their HEPA filter loading. They'll see that the air change rates, okay, they originally started at 40. Well, then 6 months later, it's at 38. 6 months later, it's down to 37. And, it gauges that their filters are still loading. You're going to go through, you test the airflows. Obviously, they'll have their HVAC guys go through and PM the units. So they know if the units aren't degrading, it's the HEPA filters are starting to load. So that's a good gauge that they'll use are the air change rates. Critical in hospital pharmacies through USP 797 and 800, they actually put in pass and fail rates for air changes in those rooms. For the longest time, it was always a recommendation. Now it's a requirement. Based on the room classification in a hospital pharmacy, they do have required air change rates that they do want to see now. The FDA is starting to get into that. GMP manufacturing places are starting to get into that as well. You'll see a lot of customers, if you get deep into their SOPs, you start working with them, they'll write their SOPs, air change rate requirements based on initial tab reports. They'll design the system, they put the system in, the certifiers and the tab guys go through, they give them the as-built clean room certification. That initial air change rate will become a target for their SOPs. It may be something they'll put a little bit of a factor in there as well, to compensate for loading and compensate for, equipment aging. But that is how they'll get their air change rates. Sometimes it may be, I've seen some as high as 600 based on an ISO 4 filling station. Some get incredibly high. So 600, you get below 600, you can't believe that they want to change their filters, but they're doing a filter change because of their SOPs. So the next IESTR recommended practice is 002.4, unidirectional flow clean air devices. In the pharmacy world, in the certification world, you may hear these being called as hoods, benches, BSCs, or primary engineering controls. That's a term that's coming out now, started in about 2016. And you're starting to hear it more and more as engineering firms get into hospital pharmacies and USP work. PEC is used in that document a lot. So poll question number 4. was, have you ever tested a unidirectional laminar flow device? Okay, good. We got a good mix there. It's perfect. I like to see it. So, good examples of that you may see in the industry: laminar flow benches, clean rooms, anything with production and filling lines. They'll have them. Hospital pharmacies use them for compounding. PCR stations, you'll see those a lot. And this also includes fan filter units. You may see them mounted in ceilings. You may see them mounted as a little isolation or a little clean booth in production areas as well. The biggest thing is unidirectional laminar flow clean air devices. They have self-contained blowers with removable HEPA filters. That's like the big that's the big indicator, is that they have their own blowers in them. Because they are ISO 5, they do have 100% coverage of the work surfaces. They'll have 100% HEPA filter coverage. With that being said, as a reminder, you're going to be using almost exclusively velocity testing. The velocity testing is used in these devices, I would say 99% of the time. There are some examples I'll mention in a little bit, but by and large, when you're testing these, you're doing velocity testing. For most of these equipment, if not all of it, when you get to one of these, the manufacturer will have the recommended data for their devices, how they're supposed to perform in feet per minute. They'll give you a range. For example, a horizontal laminar flow bench in the bottom of the slide, that may be something that they want 90 to 100 feet per minute or 80 to 100 feet per minute. You're going to use a hot wire anemometer to test that. A lot of times, right out of the document, the customer should be able to tell you what kind of apparatus they want you to use. Typically, it's the hot wire anemometer. Most of the manufacturers, that's what they're going to use in their factory tests, and that's what they're going to recommend. So to test these, to certify them the way they've been engineered, designed, and manufactured, you have to use the same equipment. There are places where you can use a single point manometer, micromanometer with single point, or a Velgrid. There are some places that do, but they're very, very few and far between. They mostly do hot wire anemometer testing. One of the biggest things, it's definitely getting into the industry more and more. You need to use a ring stand. Do not hold these by hand while you're testing it, because you may not think it's much, but you could skew the reading as much as 5 feet per minute. And when you get to a very tight zoned laminar flow device, it could be the difference between passing and failing. So when you're testing these, always have the ring stand available. So when you do unidirectional airflow device testing, they have their criteria as well for testing it, similar to a duct traverse, whether it's equal area or the log T method. They want to see a testing grid with the spaces no more than 6 inches from the sides, top, or bottom, and distances no more than 12 inches. So if you're on a 4-foot laminar flow bench, you're probably going to have 4 or 5 readings. You don't want to be more than 12 inches apart, and no more than 6 inches from the protective screen or the last point of resistance. For years and years, it used to be no more than 12, but they tightened it up this last release and said 6 inches. They want to see the average velocity recorded and individual readings laid out on the grid pattern. One of the things they do test, and a lot of these laminar flow devices, you're going to test and calculate, is the uniformity. What is the uniformity compared to the average? Sometimes, most of the vendors will use 25%. You want to have the air coming out in a nice equal grid. That's where the airflow pattern testing, like I mentioned earlier, can verify and demonstrate that the air is nice and laminar. One of the things they use the unidirectional flow for is for sweeping particles away. That's how they keep the areas clean. They'll have the work zone on a laminar flow bench, such as the one in the middle. You see the nice surface there? They'll work about 12 inches away. So they want to know that it's nice and clean. So it sweeps all the particles away and it prevents infiltration from the surrounding areas that aren't ISO 5 classified. So last but not least, as far as the standards I wanted to review go, is NSF 49, biosafety cabinetry. This is one that definitely can throw a lot of curveballs at balancers, especially if you've not really gotten into the certification world. This is one that you can definitely expect some struggles as far as between the certifier and the balancing firm. The biggest thing right now is NSF 49 is the only recognized industry standard out there for BSC manufacturers. There are other organizations that are starting to tinker with their own certifications for BSCs, but right now all the major players only use NSF 49. For their cabinets to be listed, to have the little blue NSF logo on their devices, they have to submit them and their engineering information to NSF, and then NSF does a mountain of factory tests on them. Velocity testing, particle testing, tracer gas testing, decay testing, tip testing. There's a mountain of testing that has to go on for these to become NSF listed. One of the important things and one of the revisions is that the design flows, velocities, test areas, and methods are all listed now on the unit's data plate. You will see a biosafety cabinet. It'll have a data plate on there saying what the inflow is supposed to be, what the downflow is supposed to be. They're always given in feet per minute, except for some cases where they do say CFM. So right now, currently, there are 5 types of biosafety cabinets. There's A1s, A2s, which primarily are used in a laboratory or tissue culture setting. These recirculate through exhaust HEPA filters back into the labs. They can be ducted, but they don't require ducting. B1s and B2s do require external exhaust. This is where the balancers and the certifiers will bang heads, are on B1s and B2s. C1s are newer. These are hybrid units that can be used either as a ducted B unit or it can be used as a recirculation. They have that flexibility, kind of like a soft wall or a portable clean room. They're manufactured so they can be used in the same facility for other applications. This is always one that gets them. So this should have been a poll question. I unfortunately didn't make it a poll question, but certifiers will use the flow hood for testing the inflow of a biosafety cabinet. Like I mentioned, the design inflow and velocity values are published for each model. You can see on the picture towards the top of the picture beneath the yellow tag, that's the informational nameplate for this kind of Baker Company biological safety cabinet. The preferred method for testing inflow velocity, believe it or not, is using a hood, just like the picture shows. I know for some people, myself included, when I first got into the certification world, I was stunned to see a certifier do this. I'm like, this kind of goes against everything that I've ever learned. But that's how they use them. That's how they test them. That's their recommended way of doing it. They won't call it the flow hood. When you deal with certifiers, you'll hear the term DIM. It's the same thing. So what you do is you'll tape your hood on like that. You want the hood again to fit. You want the work access opening covered up or sealed off completely. You take 5 airflow readings to get an average CFM, and the manufacturer will give you the published work access opening area. You take your area, take your average CFM divided by the area. That gives you the inflow velocity. For this kind of Baker cabinet here, they want 100 to 110 feet per minute. So you can see how the range gets very, very tight. So you'll take your hood, you tape it on, you get your hood readings, you divide it by 2.56 on this size model, and that gives you your area. So 4 B1s and B2s. So poll question number 5. This is a good one. I'm sure the senior guys will probably have come across this. Have you ever been on a project that you balanced where you have everything balanced, but then the certifier comes in and fails a BSC for low exhaust flow?
So we report to the National Standards LLC, or we use MCI.
All right, so about half of you guys have felt the pain that I've gone through before. This is why way back when I got into the certification world, because I was balancing a BSL 3 lab, and I balanced the B2 biosafety cabinets to the required 1200 CFM each via a duct traverse. The certifiers came in, and the first thing they did was fail the bio cabinets, went to the customer and said that my company said, "Oh, Dan from Danforth didn't do his job." And I had all the information. This is going back to 2003, I believe it was, this job in particular, where the certifier did that. They were a sub of ours. And they, instead of talking to us about it, they went right to the customer, and we said, okay, we'll just do this ourselves. I had a good background in it, so I got my NSF accreditation like you heard during my bio. Started doing that, got my NSF in 2008, and said, we'll do it ourselves, no thanks to the vendors. But because of this age-old debate, B1s and B2s, with NSF 49, I believe the revision was the year 2010, they have to publish a concurrent balance value. So what this is the manufacturer will make their cabinets, and they'll have two published acceptance criteria for the same point. So for the inflow, for example, for a B2 biosafety cabinet, they'll tell the balancers, we want 960 CFM total airflow. They'll tell the certifier, it'll be on the nameplate. They'll say we want 900 CFM. It takes into account a little bit of leakage. It takes into account a little bit of slop between taping the hood on versus doing a duct traverse. It'll be published for a B1 and B2. They will have this published. Baker Company, they'll have the CBV right on the nameplate. So when you're doing a balancing job and you see a B2 bio cabinet on the drawing and you're doing it by a duct traverse, you're going to traverse it to the concurrent balance value, whereas a certifier will come through and test it for a different airflow. This was their solution to the age-old debate between balancers and certifiers as to who's right. Because there's so many jobs where the balancers say they're done, here's your report, it's stamped, everything looks good, and then the certifiers come right in and fail it. So there are definitely variances that arise. Like I said, duct traverse versus hoods. That's if there's a big point I could get out of this, this would be one of them. If you're on a job with a B1, B2, look for a concurrent balance value. If the engineer doesn't even know it, you might run an RFI to the engineer, because sometimes the engineers don't even know what they are. But it is very vital to use the CBVs when you're balancing these cabinets. So one of the questions that came up, poll question number 3, I kind of left it to the end, right, is back pressure compensation. We've always heard about it. Whether it's a short ridge, whether it's an evergreen, whether it's a TSI, whether it's an Elnor, whether it's a Dwyer, they have some type of back pressure compensation on their equipment. How many people actually use it? Okay, so that's kind of somewhat eye-opening when the manufacturers, if they do say that they should be used and more than half of you guys aren't, it's a little, it can be telling. A good point of this, though, is that when they test these at the factory, they will not use back pressure compensation on the exhaust side. They'll actually take the flaps out. I've actually talked to an engineer at a bio cabinet manufacturer one time where he referred to them as speed bumps. He says, we take those speed bumps right out of there. So it's definitely different. It leads to a lot of gray areas. But that is one thing with these. You hear about back pressure compensation. Some firms use it, some firms don't. When you're using a bio cabinet, they say not to do back pressure compensation when you're doing the exhaust flow. Some manufacturers say it, NSF will ask you otherwise. Also to note, because again, like when I first got into this trade and I thought it was the nuttiest thing to use a flow hood on a bio cabinet, each manufacturer will have a secondary inflow test method that can be used in lieu of the hood. If you can't fit a hood on because you're in a tight space, you have to do a different method of testing the inflow. So it could be a restricted sash, or it could be an exhaust filter velocity measurements. These are only the only device that the manufacturers will recommend or require are hot wires. You can't use an airfoil. You can't use a Velgrid for these tests. You have to use a hot wire, and you have to have it on a stand again. If you've seen a certifier test the downflow way back when, they used to do it right at the plane of the sash, the bottom of the sash. You just hold your probe and take the readings. In 2010, they said, nope, the test plane is 4 inches above the sash glass. Again, the manufacturers will have the test intervals, how far from the sidewalls and the spacing for your grid readings, front to back and side to side, and it'll be 4 inches above the sash height. And again, you can't hold it by hand. It's an instant fail. If you go to get your NSF accreditation and you hold the device by hand for your testing, the doctor will fail you. So one of the points that I didn't make a slide for in time that I think is critical, that as we're talking about this, is when you're doing room testing like this and when you're doing laminar flow device testing like this, you want to use actual air temperatures as well. You don't want to use standard air, because a lot of times when you're reading supplies out of a HEPA filter, you're not reading 70-degree air. You might be reading 105 if it's reheating, or you might be reading 55 if it's cooling. So in closing, while the Traverse, I agree 100%, is the preferred method, in the clean room and laminar flow device world, it's just not used, and sometimes it's not practical. Hot wires are definitely preferred, and you can use Velgrids, you can use airfoils in some rare cases. The laminar flow device manufacturers will have the test methods and acceptance criteria readily available, and the newer devices will actually have QR codes on there. You can take your phone and you can scan the QR code, and you'll get the manual downloaded right to you, and for some cases, the actual factory test report. So that's all I had. I would love to hear some questions if you have any. Again, a little reminder, the CX Energy and the 60th anniversary meeting are coming up, so check your calendars and try to get there. Thank you, everybody.
Thank you so much, Dan. We got a couple questions coming in. Reminder, everybody, if you've got more questions for Dan, please put them in the Q&A. We've got a few more minutes for him to answer those questions. We've got one that says, great job explaining the requirements of obtaining flow factors for hoods by using a duct traverse. What are your thoughts on using the airfoil instrument for a duct traverse?
I actually, if you get into a space where you do not have a lot of straight duct, I do like the airfoil if the flow is turbulent. A lot of times, as anybody who's used a pitot tube will say, will understand, will know, you'll get negative readings with an airfoil, whereas a pitot tube, it'll just say negative pitot. So I think it skews your data a little bit, whereas some places, like I said, in a pinch, you may get negative readings just because of turbulent airflow. So in those cases, I do like airfoils.
All right. What instruments, in your opinion, should tab firms invest in to stay competitive in the controlled environment space?
I would say you definitely want to have, you can't go wrong. Again, I'm an older guy, so I always use short ridge instruments. So you got your ADM. I always had a flow hood with the CFM 88 meter in there, and I always kept the temperature probe in the back of that. And then you want to get a hot wire anemometer. There are different manufacturers. I'm not loyal to any brand, but do some research. Get a hot wire anemometer. They have straight probes, and they also have articulating probes. And you can get the probes that have the temp and RH on them as well, so that when you program them, you can program them to do actual temperature readings. It'll compensate your velocity readings for the actual temperature. If you're going to get into HEPA filter leak testing, that's another webinar we can definitely do down the road. We can get deeper into HEPA leak testing, and we can explain aerosol generators and aerosol photometers for leak testing filters. I could easily do a webinar for that, how to test filters.
All right. I know in your role with Integra, you're working with training. Do you have any recommendations for tab firms looking to train teams in some of these non-traditional testing approaches?
There are organizations out there that offer training. I will say, I know AABC has been working diligently to develop their own standards and training methods for their membership. It's not, obviously not ready to come to market yet, but there are some out there. If you went into clean room training, you'll get some advertisements for different companies or institutes out there. But I know AABC is working very, very hard to put that together through their CECC wing. Just like they have the commissioning side with ACG and CX Energy, they're making a big investment in time to have their own critical environment certification as well.
Any other questions for Dan? Please add them in the Q&A now. That was a lot of great information, so I'm sure there's some questions out there.
Yes, and if questions come up down the road, you can always send them to AABC and they'll send them my way, and I can always answer it via an email. So if questions come up down the road, that's obviously something I want to. It's like you're never going to hear from me again. I definitely will be around for sure to help out anybody.
Dan, is there a particular project in mind that comes to mind when you think about some of these maybe non-traditional testing approaches for clean rooms? Anything that you've worked on?
Yes. A lot of them, so as Cassie mentioned, I live in New York. I worked out of New York probably 90% of the time. We did just have a job in a different state where it was a semiconductor clean room complex where the ceiling height was 26 feet. And it had 4x4 fan powered ULPA filter units. So these are big, massive ceiling fixtures. You're not going to be able, they pump out too much air to use flow hoods on. So obviously we had to do the balancing of the air handling systems. Again, duct traverses. They fed it was a big plenum fed system. So the balancing, 90% of the balancing we did via duct traverses, and then it fed open end nozzles. So then you have to get into testing with nozzles. We found on that aspect, we used the hot wire for the velocities. We balanced all the nozzles by velocity. We knew the total airflow, and we did all the nozzles by the average velocity. When it came time to testing the air changes and giving the initial document, the as-built data for the clean rooms, because we couldn't get to the equipment because they started loading their processes underneath the ceilings, you couldn't get there. We actually had to use, in that case, we took flow hoods and we actually used them on the inlet side of these fan filter units, because a 4x4, no manufacturer is going to make a 4x4 hood skirt, and the amount of airflow was just very, very high. So we actually devised it with a flow hood and a Velgrid to set the airflows using that in kind of a non-traditional way, testing an inlet side of a fan filter unit with a flow hood. That was the first time I ever did that. And there was something like 430 of them in two clean rooms. So it was a big, massive, massive chip manufacturer.
All right, thank you, Dan. I'm not seeing any more questions coming in at the moment. We've got a couple more minutes if anybody's got one. In the meantime, we are looking forward to celebrating 60 years of excellence at the 2025 AABC annual meeting in Amelia Island, Florida. So we hope you can join us October 22nd to 24th for ocean views, networking, and expert insights with the top professionals in test and balance. Mark your calendar, you definitely won't want to miss this one. And you can learn more about that at aabc.com. We also hope you can join us September 11th virtually for the CX Energy Virtual Technology Showcase, which will be an opportunity to hear from a variety of sponsors about the latest trends and technologies in tab, commissioning, and energy management. And that one you can learn more at cxenergy.com. Not seeing any additional questions. Dan, is there anything else you want to add before we wrap up for today?
No, I'd like to thank AABC and yourself and Will for allowing me to do this. Down the road, if the membership would like, I can definitely do one a little deeper about the concurrent balance value, and I can also do one for HEPA filter leak testing as well, so that the membership knows what's behind the process of doing that. I'd love to help out any way I can. Thank you.
We really appreciate that, and we appreciate your being here today. This was an excellent presentation and discussion, and I want to thank Integra again for sponsoring this webinar. And thank you to everyone for joining us today. We hope you found this session insightful and full of takeaways that you can bring back to your own projects. Thank you, and we'll see you next time.